Good day, students. My name is Engineer Ihanacho Joshua. You are welcome to the e-learning of Intellectual Giant Eastern Academy. In today's physics lesson, we shall look into the topic scalars and vectors. At the end of this lesson, I would like each and every one of us to explain scalars and vectors, distinguish between scalars and vectors, compose at least two vectors, resolve a vector into a given direction, solve simple problems involving the solution and the addition of vectors using analytical and graphical methods. Let's go into the lesson. I would like you to pay attention and follow us gradually, step by step, to the end of this lesson. What are scalar quantities? Scalar quantities are those quantities that have only magnitudes. Example, we have distance, we have speeds, we have temperature, we have volume, we have mass of an object, etc. This is a scalar quantity. It has only mass. This is a scalar quantity. We use it to measure the amount of current. This one is also a scalar quantity that has the volume of 500 ml. All these things here are regarded as scalar quantities because they have only magnitude. Another one is vector quantity. Vector quantity has magnitude and directions. They have both magnitude and directions. For example, this is a spring balance and this is a mass. As it is, this one is a scalar quantity. This one is a scalar quantity. But if I add this to this and remove my hand, it will now move downward. Moving downwards, which means that there is a force that is acting on this, that gives us the weight of this object. By now, the movement of this has become a vector quantity because it has both magnitude and direction. Other examples of vector quantities are, we have acceleration. What is acceleration? Acceleration is the rate of change of velocity. And velocity itself is the rate of change of displacement. The displacement is the distance traveled in a specified direction. You can see that these three terms I've mentioned related together, which means they are called vector quantities. Other examples are power, weight, and the work. We now move on. We now see how to resolve scalar quantities and vector quantities. Let's start from scalar quantities. Scalar quantities, ordinarily, we add them using arithmetic methods. What do you mean by arithmetic method? Arithmetic method in the sense that you add a mass of 20 kg, another mass of 30 kg will give us a mass of 50 kg. 2 hours plus 2 hours will give us 4 hours. These are scalar quantities, how to add them ordinarily. But when we come to vectors, we don't ordinarily add vectors. We resolve vectors. For example, this is how to represent vector after resolving. This is an analytical method, the diagram of a vector, how to resolve them. Now, what do I mean by that? In this result of vectors, we look at the boards. This is the angle, because the angle must be there. The angle formed by the two vectors must be there. If we have a single vector may move in two different directions, which means we have vertical component and horizontal component. of that single vector. So this is the vertical side of the vector, and the other one is the horizontal side of the vector. Now look at this angle of these two vectors, that is combining two vectors. In general, two or more vectors acting at a body or in a body in a given direction can be combined to give a single vector. And that single vector, after resolving it, that single vector that we give the same magnitude and the direction of the two vectors is called the resultant vector. Example, consider two forces of magnitude B equals 30 newtons and Q equals 40 newtons acting on a body 0 in any of the following possible directions. Number 1, P and Q acting in the same direction. Acting in the same direction meaning that we add P and Q to give us 70 newtons. Look at number 2, P and Q acting in opposite direction. P and Q acting in opposite direction. P is 30 newtons, while Q is what? 40 newtons. And since they are acting in opposite direction, you subtract 30 from 40 to give us the value of what? 10 newtons. So the resultant vector here is 10 newtons. Now let's look into number 3. P and Q acting at an angle of 90 degrees to each other. At an angle of 90 degrees to each other, meaning that they have formed a right-angled triangle. As shown, let's see the solution. They have formed a right-angled triangle. In solving this, there are two ways of solving this, which means you will not use either scale method or you will not use formula method. Let me interpret this one of scale drawing. Using scale drawing method, since we have 30 newtons, we have 40 newtons, 30 newtons, you now say, let 1 cm represent 10 newtons, which means 30 newtons will now give us 3 cm. Again, since 1 cm is representing 10 newtons, 40 newtons will now give us 4 cm. You now draw a right-angled triangle. Using that scale, you have here is 3 cm, so ruler you measure it. Here is 4 cm, so ruler you measure it. When you must have done this, take that to your ruler, complete this, because this will form a rectangle. Rectangle, two parallel sides are equal. This here is 3, meaning that here is also 3. Here is 4, meaning that here is also 4. Which means we will now draw a diagonal to cross the center of this rectangle and then use your ruler to measure it. If you measure the length of this to this, you will get approximately 5 cm, which gives us the resultant vector. Another method of solving that is using Pythagoras theory. In Pythagoras theory, you will now see that R equals P plus Q, which is ordinary, but using Pythagoras theory, we have that R equals P squared plus Q squared. That will give us the square root of P squared plus Q squared will give us the resultant effect of the what? Vector. By then, we will now see it as, if we now substitute that, we will now get the answer as 50 newtons. Now, the third question there, the first question there is, if they form an angle of 120, forming an angle of 120, means that our theta there is what? 120. Our theta there is 120. In that case now, we now, since 120 is not in the first quadrant, 120 is in the second quadrant. What do? We subtract 120 from 180 to give us 60 degrees. So the angle will now be 60 here because you are looking for, if you go to your fourth grade table, you cannot see 120. you cannot see 180. You will see from 0 to 90. And since you are talking about 120, we now subtract 120 from 180.